All right, I had a request for Pythagorean Theorem from someone getting ready to take the the ASVAB. So I'm going out of order and jumping all the way to geometry, chapter 9.1 here. But the Pythagorean theorem works with right triangles. And if you're looking at a right triangle, you have two legs and a hypotenuse, which is your longest leg. And if you're trying to find one of these missing legs, you can use the formula c squared equals a squared plus b squared. Normally you hear it a squared plus b squared equals c squared, but there is a reason that I like to do it in this order that I can explain at a different time. So the c has to be the hypotenuse. That will be the one I'm looking for. And it doesn't matter if the a and the b are in different places, but that c has to be by itself on one side of the equation. Now, I've always told my students for the a squared, it doesn't matter, but I just use the smaller one, which is the 5 squared. And then for the b squared, that's going to be 12 squared. So c squared equals 5 squared means 5 times 5, which is 25. And 12 squared means 12 times 12, which is 144. So we've got c squared equals 125 plus 144, which is 169. Now, if you're trying to get the c alone and it has a square with it, the opposite of square is square root. So I'm going to take the square root of both sides. And I have c equals, the square cancels the square root out. C is now isolated. And I have to ask myself, what will give me 169 when I multiply it by itself? The square root of 169 is 13. If you're not sure how to get that, find your button that looks like this. It's going to be second the square root of 169, and that will be 13, because 13 times 13 is 169. Now 5, 12, 13 would be referred to as a Pythagorean triple. And if it's a Pythagorean triple, it just means that each of the three numbers are integers that are positive, and they're not decimals or fractions or square roots. They're just these whole numbers. So 5, 12, 13 normally shows up on every single test I've ever seen, especially any kind of standardized test. So if you see 5 and 12 and you just remember that it's a Pythagorean triple, then you know the other one, the longest one, would have to be 13.